Hi, everybody. Welcome to Satellite 2020. Sorry we got off to a late start. DC traffic is a killer. But my name is Jeffrey Hill. I'm the conference chair, and I'm here with Elon Musk, chief engineer and founder of SpaceX. Elon, thank you so much for being with us.
Thanks for having me. I guess it was 11 years ago that we met.
Yeah, and when we met 11 years ago, we were talking about Falcon 1, Falcon 9 at the time. And when I asked you, what's the point of all this, you said, it's to send human beings back into space on a US-built rocket from a US-built facility so that we could permanently resettle other planets. And here we are, we're right on the brink here of sending humans back into space. The Crew Dragon is in Cape Canaveral. How do you feel that you're on the doorstep here?
Yeah, it's great that we're about to launch people to orbit. It's been a long time.
Long road.
18 years.
Yeah.
Kid could be in college by now. Yeah.
Is it like sending your kid off to college?
Well, we haven't done it yet, but it's a long time.
You're packing the bags. You're ready to go. Can you talk about the road from the space shuttle to the Crew Dragon? Like, talk about what are some of the challenges that you faced in creating a human-rated spacecraft for human space flight? What were some of the challenges that you encountered along the way?
Well, the thing that concerns me most right now is that unless we improve our rate of innovation dramatically, then there is no chance of a base on the moon or a city on Mars. Yeah, this is my biggest concern. I mean, Crew Dragon we've already taken it to the space station and back.
Mm-hmm.
You know, so a lot of people aren't aware of that. Mm-hmm. We just had like basically a dummy, you know. So. And then since then we've done massive amount of testing, you know, pushing all the corner cases, and just a truly ridiculous amount of testing. It's like definitely hat us off to the Dragon engineers and supporting team at NASA for going through a truly staggering number of tests. Now that said, Dragon really is just a low Earth orbit transport vehicle. Mm-hmm. It's really just, it's capable of taking a few people at what is still a very high cost to Earth orbit. I mean, technically we could send people around the moon on Dragon, but I'm not sure we'd want to. It's too small. Mm-hmm. You know. So. It's good to get this done, but I think we need to be very careful of getting stuck in a local maximum. Mm-hmm. And you know, the space shuttle was something that was really stuck in a local maximum for a long time. Mm-hmm. And yeah, we don't want to be that situation. I mean, frankly, why does Soyuz still fly? I mean, Korolev is probably turning in his grave right now.
Right. It's an interesting question.
It was designed in the 50s.
Yeah, right.
If you told Korolev and the other guys that we'd still be flying Soyuz in 2020, they'd be like, that's crazy. Yet we are. So we don't want to be in that situation, you know. It's a solid vehicle, it's just like it's time to move on.
Right. Right, and so I know we started late. I sourced a lot of these questions from the public and the audience. We're also going to do a Q&A here. So I'm just going to jump right into the questions that we received. So, I mean, the most popular question we got was like, what are the greatest challenges or the biggest challenges we face in expanding our presence in space and exploring and eventually resettling new worlds?
There's really just one thing that matters, that is a fully and rapidly reusable rocket. That's the one thing that matters. And it needs to be reasonably big, or your payload to non-payload ratio will be kind of whacked. won't be good. So just like you wouldn't want a super tanker growing, like container ships, you have a container ship with thousands of containers. You don't, have like a bunch of tiny ships with little outboards on them cruising across the Pacific. That would be silly. So you have big ships when you want to go long distances with serious cargo. So we need a fairly big, but definitely rapidly and completely reusable rocket. This is the fundamental thing. Without that, we're going nowhere.
And what level of reusability is SpaceX actively pursuing for Falcon 9, for Dragon, for Starship?
I think Falcon 9 and Dragon have, they're asymptoting, their technology architecture is asymptoting, meaning like it really would not make sense to have a Block 6 Falcon 9, from where we are right now. It just doesn't make sense. That's why we have a big focus in terms of new technology development on Starship. For Falcon and Dragon are kind of like operational vehicles at this point. So they're good products. They're operational, but there's not really. We need a whole new architecture, and that's what Starship is about. Mm-hmm. And Starship needs to be fully and completely reusable, and rapidly so. It's being designed for about to be relaunched an hour after landing, with zero nominal work. Like you could have scheduled maintenance, or you could have like something like a squawk issue, just like commercial aircraft. But you're expected. The only thing you expect to change on a regular basis is propellant, and it's got to be fast. So now for the ship, you got to wait unless you're launching due east from the equator. You've got to figure out some way to get the ship orbital ground track to pass over the landing site. Otherwise, you're too far away. So the ship it might take 3 orbits, 4 orbits maybe to get back over the launch site. But I think we want to aim for a capability of 3 flights a day for the ship. Wow. Most of which is taken up with getting the orbital, ground track to come over the launch site. Mm-hmm. Yeah. And then an hour for everything else.
And everybody's interested in the mission to Mars, planetary resettlement. When we're talking about reusability for the launch vehicle, what are your thoughts on in-space resource utilization? For example, water, oxygen, soil, from the moon, perhaps, maybe to go to Mars. Do you have any plans to utilize resources in space for the mission to Mars?
Nope. I mean, apart from orbital refilling, I think that's very important. So you've got to. So there's one besides a fully and rapidly reusable rocket, you need to also have orbital refilling or retanking. That's got to be. That's fundamental. Because then you can essentially recoup all of your mass fraction delta V in Earth orbit. You can leave with full tanks, and it could be from low Earth orbit, or something that's maybe elliptical or something like that if you want to go higher energy. But that's crucial for getting to Mars. The moon is neither here nor there. Using the moon would be like, okay, if you want to cross the Atlantic, maybe you want to go to Iceland, probably not, But, to visit, sure, but it's not like a mandatory stop,
Right. Yeah. And also, for the mission to Mars, what advancements, we talk a lot about hardware and physics problems, and what about advancements in software? The reason I bring this up, recently, are you familiar with the game designer Jonathan Blow? he referenced you in a keynote he was given, and he said that you had talked about technology naturally decays because skills naturally fade. And one of the things he identified was a decay in software, degradation in software. Is this something we have to address in doing something like going to Mars, and since all of this stuff runs on software?
Well, software is an increasing part of any piece of technology. I mean, Tesla, the car is extremely configurable. It's basically like a laptop on wheels. So software matters enormously there. And really, for example, for full autonomy, the only gating factor is software. The hardware is all there that's required. It has been for the last couple of years. Well, the final piece of hardware was upgrading the computer to have more compute power. So software is extremely important. The point you're alluding to, which is that, what I was referring to is technology does not automatically improve.
Right.
People are used to the phone being better every year. Although, and I'm an iPhone user, but I think like some of the recent software updates have been like not great. Certainly feeding it to that point. It like broke my email system. Like what the? This is like quite fundamental. So yeah, there sure is a lot of software out there, and some of it's like the people that wrote it are retired or maybe dead. So like now, how do you fix it? It's going to be an issue. I think we definitely need a lot more smart people working software.
And not just troubleshooting old problems.
Not just troubleshooting old problems. It's actually very important to retire old code bases and not just maintain them forever, because the difficulty of maintaining them becomes extremely high. Yeah. And at a certain point, you just got to redo the code base.
So we'll come back to the Mars mission because I know we've got some audience questions on that. We're at a satellite conference, so I'm going to ask you some questions about satellites. Starlink. What's the long-term vision for Starlink? How do you see the role of Starlink as it relates to mobile, broadband, and 5G?
Sure. So, I mean, the whole purpose of SpaceX is really to help make life multiplanetary. But the revenue potential of launching satellites, servicing the space station and whatnot, that's, taps out around $3 billion a year. But I think providing broadband is more like an order of magnitude more than that, probably $30 billion a year, as a rough approximation. And we're still like probably below 5% at that point. So it's not like, I want to be clear, like, it's not like Starlink is some huge threat to telcos. I want to be super clear, it is not. In fact, it will be helpful to telcos because Starlink will serve the hardest to serve customers that telcos otherwise have trouble doing with landlines or even with cell radio stations, with cell towers. 5G is great for high density situations like being here in DC or New York, San Francisco, that kind of thing. 5G is great for high density situations, but it's actually not great for the countryside. For rural areas, it's not great. You need range, and so any kind of sparse environment, 5G is really not well suited. But it's great for city dense city situations. So Starlink will effectively serve the 3 or 4% hardest to reach customers for telcos, or people who simply have no connectivity right now, or the connectivity is really bad. So I think it will be actually helpful and take a significant load off the traditional telcos.
Okay. And I was going to ask you what customers were ideally suited for Starlink, but I guess since you mentioned that it would be these 3 to 4% at the very
something like that
at the very edge. What is the customer experience like then for those people, and what's the cost of acquiring the services?
Well, it will be it should be a good experience because it'll be very low latency. And we're targeting latency below 20 milliseconds. So somebody could play a fast response video game at a competitive level.
Right.
Like that's the threshold for the latency. So then, and bandwidth. Bandwidth is a very complex question, but let's just say somebody will be able to watch high-def movies, play video games, and do all the things they want to do without noticing speed.
Right.
And then the challenge for anything that is space-based is that the size of the cell is gigantic. You know, so it's like I said, it's great for very low to maybe mediums, sort of sparsity situations, but it's not good for high density situations. We'll have some small number of customers in LA, but we can't do a lot of customers in LA because the bandwidth per cell is simply not high enough.
What does the equipment on the ground look like for this? What are
So the ground equipment just looks like, well, I think it's, like I said, I think it looks like looks like a UFO on a stick. So at least the version 1 of the user terminal will actually have actuators on it so that it can improve the pointing accuracy. So you don't have to. It's very important that you don't need a specialist to install. The goal is that the instructions in the box there's just 2 instructions and they can be done in either order. Point at sky, plug in. And you do it either order, sequence doesn't matter, and it will work.
plug and play?
Literally, but also point at sky. You can't see the satellites. If you can't see the satellites, it can't see you.
Just wanted to talk about just some of the design concerns that were raised by astronomers. Can you talk about a little bit about how you working with astronomers to alleviate these concerns, or are you working on the design or altering it, or are the concerns overblown? I mean, how do you feel about what has been raised?
I am confident that we will not cause any impact whatsoever in astronomical discoveries.
Okay.
0. That's my prediction.
So you're not launching them?
We'll take corrective action if it's above 0.
So you're not giving like Orion a hat or anything like that? Everything's...
No, I mean, sometimes people get a little excited because when the satellites are first launched, that they're tumbling a little bit, so they're going to blink, and because they haven't stabilized, and they're raising their orbit, so they're lower than you'd expect, and they're kind of necessarily going to reflect in ways that is not the case when they're on orbit. But now that the satellites are on orbit, I'd be impressed if somebody can actually tell me where all of them are. I've not met someone who can tell me where all of them are, not even one person.
Interesting.
Yeah. So it can't be that big of a deal. But we are to be clear, we are actually working with senior members of the science community and senior astronomers to minimize the potential for reflection of the satellites. So, we're running a bunch of experiments to, for example, just paint the phased array antenna black instead of white, and we're working on a sunshade because there are like certain angles where if the sun gets just right, and there's not like a little sunshade, we're not talking about a lot here, then you can get a reflection. And so we're launching a sunshade, changing the color of the satellites, and otherwise minimizing the potential for any impact. Even like aesthetically, this should not be an impact, I think.
Recently, Gwen Shotwell in Bloomberg was quoted as saying that you were exploring splitting Starlink from SpaceX. Could you talk a little bit about that, why that would happen, and how you see both of these independent companies functioning, and just talk a little bit about that?
We're thinking about that zero.
We're thinking about that what?
Zero.
Zero?
Zero.
Not thinking about it at all.
We need to make the thing work. It's far from obvious that, I mean, it's real important to just set the stage here for LEO communications constellations. Guess how many LEO constellations didn't go bankrupt? Zero.
Right.
Zero. Iridium's doing okay now, but the Iridium 1 went bankrupt. Orbcom went bankrupt. Globalstar bankrupt. Teledesic bankrupt. Am I leaving anyone out? There's a bunch of others that didn't get very far that also went bankrupt. Anyway, they all went bankrupt.
So you're focusing on making it work first?
Not bankrupt.
Right, and not going to...
That would be a big step. To have like more than zero in the not bankrupt category.
How would you, I mean, how does it work then with the business of SpaceX, since you're like, I mean, you are launching other constellations. Is that an issue? Does that cause a conflict, or?
We're launching other constellations?
Or you're launching other satellites.
Yeah, sure, whatever, yeah, no problem. Of course.
Right. So there's no like,
We're even giving them a good deal, by the way. Like, no problem. You want to launch constellation on SpaceX? Sounds good to me.
So,
I mean, I think that, I think there's the world seems to have an insatiable appetite for bandwidth. So we're certainly happy to launch other satellites, and we don't think Starlink is going to destroy all other satellites or something like that. Or definitely not.
Okay. All right.
Yeah, we just want to be in the not bankrupt category. That's our goal.
Since you're now the company of SpaceX, now you're building or launching satellites. Are you looking at expanding the business of SpaceX into other areas of commercial satellite connectivity? Maybe like we talked a little bit about you're already building like technology on the ground. Are there other areas that you're looking to get into in terms of commercial space connectivity or satellite services?
No, there's two major new technology programs at SpaceX. That's Starlink and Starship. Well, it kind of has star in the name of it too much. Maybe we should call it like Link and Ship. If you divide the one by the other, the stars net out, and then it's just Link and Ship. But that's it. As far as I know, anyway. And there could be some secret project that's so secret I don't know about it.
You don't have a business under the chairs.
I don't think there's anything major.
Okay. So I want to give time for people in the audience to ask some questions. But we talked about Starship. So development at Boca Chica is moving along pretty quickly. And
yeah, actually, that was the real reason I was late. Is because I was at Boca Chica. My apologies. I was just working on Starship with the team there. So it's pretty cool out there. Actually, I like it.
And tell us a little bit about the work that's underway, what we can expect in the future for Starship.
Well, we're building a production line. Production line is the hard part. Making one of something well, at this point, like frankly, designing rockets is not that hard. Especially if it's an expendable rocket, it's not really a hard problem. You can literally read books that'll tell you exactly how to do it. The hard part is now actually building that thing even once is hard. And then building a production line is 1,000% harder, like at least 1,000% harder.
Yeah.
Maybe more. So just in general, production and manufacturing is underappreciated, I think, especially in the US, frankly. So we should really pay a lot more attention and care a lot more about manufacturing. This is This is an honest day's work, let me tell you.
Also, what inspired some of the design aesthetics of the spacecraft? I mean, stainless steel, it's a striking design for a spacecraft. But what inspired your vision for the way it looks, the way it functions? Like, why stainless steel? Why?
Well, we were going to make it out of advanced composites. And the advanced composites, they cost like $60 a pound, or $60 a kilogram, like a little more than that, maybe $130 a pound. And there were 60 to 120 plies for the tank. It was taking forever. We weren't making good progress. Cost crazy money. And I was like, okay, switching to aluminum lithium is also a pain in the neck. We do that. That's what we use for the Falcon 9 tanks, because it's hard to weld because of the reactivity of the lithium. So, you know what's easy to weld? Steel. Steel is really easy to weld. And stainless steel doesn't even require paint. That sounds great, because the paint shop's a pain in the neck. And you want to try painting something that's got to drop to cryogenic temperatures and then bend a lot? It's like, forget it. I mean, that paint wants to come off like there's no tomorrow. It does not like to stick. So then you could use special paint. And then the special paint also can't get, like when you're going vertically at like supersonic, you get the basically static electricity buildup called triboelectrification. Although it reminds me of the trouble of tribbles. But you can basically zap yourself if you have paint with the wrong paint. You know? So anyway, no paint is great. So we need a big ass paint shop for Starship. You know?
One less problem to think
One
about.
less problem. And paint doesn't weigh zero.
Right.
You know, they used to paint the shuttle external tank white, but then they're like, well, we're adding a lot of weight to this thing, and it's a big pain in the neck, so we'll just have it stay orange.
Yeah.
So just not painting it is great. So then, you know, and we're not the first to use steel. Like they used 301 in the early Atlas program. Charlie Bossert, I think it was his idea. Obviously, other people involved, but Charlie Bossert, by the way, that guy is underappreciated. He kicks ass. It's really great. You should read about his stuff. He's awesome. So he used 301. So obviously, it's not a new alloy. I think we're going to start switching to a different alloy pretty soon, and then just tweak the alloy constituents, because we should be able to do better in 2020 than they did in like the 50s, you know. So I mean, come on. So I think we'll probably start switching away from 301 maybe the next month or two. Okay. Now the funny thing is that, like, I actually knew that steel, especially 301 full hard steel, couldn't be that heavy because the original Atlas had a very good mass fraction, right? So it can't be that bad. If you look at the normal sort of standard material sheet for 301, it will usually not tell you that it work hardens dramatically and improves the strength dramatically with work hardening, and also at cryogenic temperatures, it improves strength dramatically. So then if you combine the work hardening with the cryo strength improvement, you get an effective strength to weight that is about the same as an advanced composite. Now people will generally make a mistake with composites because they'll look at the material sheet and not realize that, okay, with composites you've got to have a big knockdown, because you basically have, composites are string and glue, and so you can't just like have, like, let's say your problem calls for having 4 plies of carbon. You can't just have 4 plies. You need like 5 or 6, because in case you damage one or something like that. And you have to say, what's your worst case allowable for a D bond or something like that. So the actual knockdown you end up taking for composites is more than you would for a metal structure. So people often, so it's like a classic newbie mistake is to overrate carbon fiber. Because you look at the material data sheet and it looks like an obvious move, but it's not. So anyway, so at cryogenic temperatures, the steel has a de facto strength to weight about the same as advanced composite. And that doesn't not even counting the fact that you have to paint the composite, you don't have to paint the steel. Right. Then there's another factor, which is if you want to have a reusable vehicle, it's going to get hot. Right. Composites don't like getting hot. So, typically your composite maybe is comfortable up to around 150, 200 Celsius, something like that. And things start getting pretty sketchy around 250 C. I mean, like you start having to use advanced resins and all that kind of thing. So, whereas steel's pretty happy at 1,000 C, no problem at 500. Considered 500 C all day, and brief periods of 1,000 C, no problem. So then, for a reusable vehicle, you now need zero heat shielding on the leeward side. Normally, you need some heat shielding just due to radiative heating on the back. So you don't have a lot of convective heating at hypersonic, but you have radiative heating. And then you can thin out the windward side of the heat shield because the thickness of the heat shield tile is driven by the temperature on the back side of the tile where it mounts the primary structure. So if your primary structure can take a high heat, that means you can thin out the tile. So think of it like these, like oven mitts or something. Right. If you have like, how hot can your hand go, and that sets how thick your oven mitt is. Right. So then you can have, like I said, no heat shield on the leeward side, and a thin heat shield on the windward side. So now your actual total mass of a steel, of a reusable steel spacecraft is less than that of the most advanced carbon fiber vehicle you could possibly imagine.
Yeah. Wow.
But this happened by accident, by the way. This may sound like some great insight, but it actually happened because we were moving too slowly on composite, and I was like, we cannot move this slowly or we'll go bankrupt. So just do this with steel.
So the design has to be focused on problem solving, otherwise you're going to spend too much time trying to figure it. You don't start with
Yeah, I'm like sort of taking to management by rhyming. If the schedule is long, your design is wrong.
Right.
This is very true.
That's good point.
Yes.
With that, I want to go to some audience questions. We asked the audience through the app to submit us questions, so I believe we have a few that we've pulled here. So we've got some over here. Can we? And can you come closer over here so we can see you? Let's say. All right. Our first question.
Hello, I'm Jaden Zundel. I'm a graduate student at Stanford. My question for you is, as you look back on your career in the space industry, what has been the most surprising or unexpected challenge that you faced? And along those lines, if you were to go back in time and talk to your 20-year-old self, would you do anything differently?
Go back in time to your 20-year-old self.
I mean, I think I think it would make far fewer mistakes. Obviously, if I could go, like, here's a list of all the dumb things you're about to do. Please do not do them.
Wouldn't we all?
It'd be a very long list. And like, here, let me write it down or something. I mean, hindsight's 20/20, so it's hard to say. I mean, I've made so many foolish mistakes. I have lost count, honestly. I mean, some of these things I just wish like that's simple sort of mantra, management by rhyming. I mean, it worked for Homer, okay? But management by rhyming is that thing I was saying, like, if the schedule is long, the design is wrong. we've overcomplicated the design many times. And I think we should have just gone with a simpler design, with the acid test being, how long will it take for this to fly? And if it's going to take a long time, don't do it. Do something else. If you look at, say, Falcon 9, it's got an aluminum lithium tank, but then the unpressurized structures are carbon fiber composite. And really, one of the worst possible things you could do to a joint is take something with a high coefficient of thermal expansion, high CTE, take it from room temperature to cryo, and then connect it to something that has 0 CTE, basically 0, like carbon fiber. So now you've got a real pain in the ass joint, basically.
Right.
So in order for that to work, you've got the tank's got to shrink radially, and you've got these super expensive, heavy bolts that are like a beam and bending across, that are then taking load into the interstage, and they desperately want to shear off or snap off. This is crazy. Really you should just have a continuous metal structure. That's obvious. That should be done. That'd be way better. Things expand to fully available resources. So then, like sometimes you should say no to things that you don't. Like the original Falcon 1 team, which did the fairing, tanks, engines, everything pretty much, was maybe a little over 100 people.
Okay.
And now SpaceX is like 6,000 people, I think, something like that. So really just simplify your product as much as possible. And then like if I think of some of the ways in which, how does a smart engineer make dumb mistakes, including, is optimize something that shouldn't exist. Don't optimize something that shouldn't exist. But people are trained to do this in college. You can't say no to the professor. The professor's going to give you the exam, and you've got to answer all the questions, or they will get angry. And give you a bad grade. So then you always optimize you always answer the question. A lot of the times you should say this is the wrong question.
Right.
In fact, the question is definitely wrong to some degree, just how wrong. And I think just generally taking the approach that your design is some degree wrong, probably a lot more than you think. Your goal is to make it less wrong over time.
Do we have let's go to another question.
Hi, my name is Julie Seven Sage, and Mr. Musk, you have said in the past that you think that college degrees shouldn't be that important, and that has been showed in job listings in places such as Tesla. However, in places like CIS industry, including even at SpaceX, in the satellite development area, many of the job listings say that you need at least a bachelor's degree and prefer at least a master's degree. So my question to you is, with more jobs asking for higher levels of degrees, that scholarships are not changing amounts, and that it's getting harder and harder every year to pay tuition, even with using scholarships, how can colleges and industries make it easier to afford college, but at the same time being able to pay grad students and employees well, and also to make sure that there is a large-scale access to good colleges, especially to underprivileged communities, so that everyone can be a part of the future we're building? Thank you.
Well, first of all, you don't need college to learn stuff, okay? Everything is available basically for free. You can learn anything you want for free. It is not a question of learning. there is a value that colleges have, which is like, seeing whether can somebody work hard at something, including a bunch of sort of annoying homework assignments, and still do their homework assignments, and kind of soldier through and get it done. That's like the main value of college. And then also, if you probably want to hang around with a bunch of people your own age for a while instead of going right into the workforce. So I think colleges are basically for fun and to prove you can do your chores, but they're not for learning.
There it is. I know we started late, and I know we don't have much time left, but to build on Julie's question here, how does somebody like you with a very long-term mission of going to Mars, how are you cultivating the next generation of leadership to take you there? Because I mean, this is a long-term project. We might not be around to see us finally resettle on Mars, or maybe.
No, I mean, I hope I'm not dead by the time people go to Mars. That would be a great outcome, I think. I might be, if we don't improve our pace of progress, I'm definitely, going to be dead before we go to Mars. So I'm just like, would like to not be dead by the time we go to Mars. That's my aspiration here. So if it's taken us 18 years just to get ready to do the first people to orbit, we better improve our rate of innovation, or, based on past trends, I am definitely going to be dead before Mars. So, we've got to improve our pace of innovation a lot. So yeah.
I guess what I would say is, I can tell you can see. How do you communicate that vision that you have to somebody who could maybe take over for what you're doing, and to see things the way you're seeing them in terms of the mission?
Well, we have a lot of good people at SpaceX. That a lot of really talented people. In fact, I wonder, like, sometimes how we can make use of their talents in the best way, because I think we're often not using their talents in the best way. Yeah, but to the point of the question that was just asked, I want to make sure Tesla recruiting does not have anything that says requires university, because that's absurd. But there is a requirement of evidence of exceptional ability. Like, you just can't, if you're trying to do something exceptional, they must have evidence of exceptional ability. I don't consider going to college evidence of exceptional ability. In fact, ideally, you dropped out and did something. I mean, obviously, look at, Gates is a pretty smart guy, he dropped out. Jobs, pretty smart, he dropped out. Larry Ellison, smart guy, he dropped out. I'm like, obviously not needed.
So,
did Shakespeare even go to college? Probably not.
well, thank you so much. I wish we could take more audience questions. I know we have a hard stop, but thank you, Elon, for stopping by. Thank you. Let's give him a round of applause for stopping by and speaking to us. Enjoy the rest of your evening, and we'll see you soon.
Right.
Thank you very much.
All right.